Okay, so welcome to Women Coding Community. We support women in developing their tech careers. I'm sorry, just a second. Okay, so we are committed to creating a culture where every woman feels valued, supported, and empowered to thrive in tech. How are we doing this? We organize and offer different forms of education, mentorship, also community building, and offer career services. We provide different workshops and events like this one tonight, online and in person. And we also connect our members with the mentors. We build a supportive community and also try to raise awareness for more inclusive industry practices. We have a code of conduct. As we are an open community and inclusive community, we kindly ask of you to be nice to each other. And to read our code of conduct, it is here on this link on our website. I'm sorry. And please, if you notice anything that is not aligned with our code of conduct, inform us. You can use this email or Slack. So as I said, we offer different projects. One of our biggest projects is a mentorship program. We offer a long-term mentorship program that is lasting from April to November. And we also organize short ad hoc sessions with our mentors, so you can join, for example, for just 1 hour and discuss any topics of interests. We also have many other activities, as you can see here, and on this slide as well. We offer study groups and technical groups. We can also help you to practice for interviews, and if you want, you can send your CV and we can offer our feedback and suggestions. So, for example, we are starting with lead code study group from June, and here you will be able to practice your coding skills. We are having also test-driven development study group that you are now joining. We also offer many others, and you can find them all by joining our Slack channel. So here is a code, but we will also share links in the chat, and it is also accessible from our web page. We are always also accepting and are happy to get new volunteers. So as a volunteer, you can help us organize events. You can also give a tech talk. You can contribute to our open source projects as backend or frontend engineers, or you can also help us with the design of the pages and as a project manager. So many different ways in which you can volunteer to the community. And again, you can find a link to volunteer application form on our web page. As a volunteer of the community, you are going, of course, to learn a lot. You will improve your technical skills, your soft skills. And the most beautiful thing of all is that you are going to build a network with like-minded people and make friends. So by contributing to the community, you can also, you will get experiences that you can put in your CV and get our recognition. Sometimes we also organize events and offer tickets, free tickets to different online and in-person events. So thank you for joining us today. And please check our page and join our Slack channel. So now I will just stop sharing because I want to announce our speaker tonight. So welcome, Wilson Adenuga. I hope I have pronounced well. So Wilson is thank you. Wilson is a full stack engineer with expertise in various technologies and programming languages. He has led projects across the fintech, healthcare, and edtech industries. He's also experienced in database design, web accessibility, and test-driven development. Wilson enjoys sharing knowledge and mentoring, and he volunteers as a mentor for women coding community, as well as an open source contributor. Wilson is also founder of Wilson's Digital Empowerment Foundation, which is organizing digital training programs for youths and rehabilitation care homes in Lagos, Nigeria. And he is also founding engineer at Reporta Insights, a digital fraud prevention platform used across Nigeria's banking sector. Please welcome our mentor and teacher today, Wilson Adenuga.
Hi, everyone.
Welcome.
Thank you so much.
Thank you.
So I'm just going to share my screen right now, and we can get started. Okay. Screen. All right. Yeah. Please let me know if you can see my screen. Yeah. Oh, awesome. Okay. So my name is Wilson. Like I said, a software engineer, mentor, and also open source enthusiast. I mean, you can find me on LinkedIn, Twitter, and on GitHub. So like my handles and stuff. So you should follow me if you like, I suppose. So today, I mean, I don't need to introduce myself again. I think that's already been done. So I'm going to just go straight into it. So today we're going to be speaking about test-driven development, and we'll have like 4 sessions. So it's basically going to be backend and front-end. So we're going to cover everything: backend, front-end, test-driven development. Yeah, but it's going to be in JavaScript or TypeScript, front-end and backend. So that's what we're going to be discussing throughout the 4 sessions. So today is just like an introduction to test-driven development, what kind of tools you can use, what are the benefits of test-driven development. Then in other sessions, we'll go into in-depth, we'll explore in-depth writing front-end code, testing it out, refactoring, and seeing what TDD does for us. And then we'll also go into backend, write some APIs basically, and just see how we could integrate TDD into our workflow as software engineers. So this is the agenda for today. We're going to do a bit of introduction to TDD, and then also talk about some type of test that we have, some tools you can use, and then we'll go to like write some tiny code, just a few lines of code, just to, I mean, software engineers are doers, not just speakers. We speak and we do. So I mean, it's nice to do some, like, show some examples, just and then I'm just doing this small exercise, just write a small function like I've done, like I'll do in the live demo, and then you just write your test yourselves, I guess. Yeah. So that's like the agenda for today. Yeah. So TDD. So what exactly is TDD? So TDD is the short form or the acronym for test-driven development. So it's basically a development approach where you write your test, then you write your code. So say I want to write a function that adds 2 numbers together. I'll basically write my test to assert the outcome that when I add 1 + 2, I get 3. Then I'll go ahead and write my code to say, okay, I have the test, then I write my code. The test should pass if my code is correct, basically, and it should fail if I've written the wrong code. Then I can refactor and all of those things. So TDD follows like this. The principle is red, green, refactor. Means you write your test to fail. Then you make it pass, and then you can basically refactor your code, knowing that you've written your test. And if you refactor your code, it should still pass, right? Because your test says everything is good. So that's like the old TDD principles. Even though at times, I mean, as software engineers, even me, I mean, at times, I write my code first, then I write my test. I mean, at the end of the day, I'm sure after writing my test, I can sleep well at night knowing that, okay, I've written the test, even though I didn't really follow the principle, right? I wrote the code first, and then I'm writing the test so that, okay, at least every base is covered with my test. I mean, but the principle says you write your test, you write your code, your test will fail at first. When you write your code, your test will pass, you can refactor your code, and then everything is fine. But I mean, we're engineers, sometimes we take shortcuts, I guess. But then it's always good to, at the end of the day, whatever approach you take, if you decide to take the TDD approach, which is what is good and the right way, or if you decide to write your code and then write your test, it's always important that you add tests to your code. It makes you sleep better at night and you have confidence in your code. And then any engineer that's coming on board, say later on, they also can read your tests, like a form of documentation for your code. I mean, if I join a company and I basically read their test, I open a page or a function or an API, and I see test, I always read the test first because that gives me like an understanding of what the code does. So, so I'm just going to read out the benefits I've written here. First one is safe refactoring. So I have a piece of function, right? And I was given I invented a code, and I'm in the code. There's like 5,000 lines or 3,000 lines or even 10 lines, and I think the code can be refactored, can be cleaner, can be better. So if there's test, I could read the test and say, okay, this is what the code does. I could easily go and refactor the code and still run the test. If the test passes, I'm sure I didn't break anything, right? The alternative would be I would refactor the code if there's no test, right? I would refactor the code and then I would have to test manually, maybe launch maybe my Postman if it's API. And God help me, before I get to that stage, I have to register, I have to log in, I have to do some steps before I get to that stage. That's like time wasted, right? And God help me, I test what I've refactored, the code is breaking. What I have to do is go back, refactor, come back, test manually on Postman. But then if you have test, you could easily just run a command on your terminal and then you see the outcome. It's much more faster, it saves time, and you can go on refactor as much as you want. And you run your test, you're sure you didn't break anything. So that's like a very key advantage of adding tests or test-driven development for your code. It's also like I said earlier on, a form of documentation. If I read your test, I should have an understanding of what your actual code does, like just by reading your test. So it's like a form of documentation. Faster feedback loop. Like I said earlier, say for instance, there's no test and then I refactor the code. I have to go and test manually. Say for instance, if there are a lot of steps or even if it's just one step, I have to test manually, launch my Postman or launch my web browser if it's like a front-end application and test manually. And go back, refactor. But I mean, with tests, it's easier. I run my test, I say, oh, it's breaking. My refactor is not working. I've done something wrong. I just undo undo everything and say, okay, I'm not doing this. I just try other steps. It's faster. I get my feedback instantaneous. Like it's super easy. Also improved code quality. So with test, by writing your test, so I've noticed something or some people do something or in certain scenarios you might see like you open a file, a JavaScript function, and it's like 500 lines of code. If you have to write tests for that code, you would sweat it. Like it's going to be very stressful, right? But what TDD forces you, or like tries to do for you, it helps you to write modular code. because you know you're going to write tests for that code, you would try and make it as modular or as small as possible. Maybe single responsibility does just one thing or two things. It's small, it's precise, and then your code becomes modular. So just putting everything inside one file, and then when it's time to test, so it's like, oh, what am I even going to test for? If it's small, it's modular, it is maintainable, it is easier to test. So TDD does that for you when you write your test. It forces you in a way to write good code, to write modular code, because it's easier to test, and then you can always bring it together to instead of writing one long function or one long component, break it down into simpler components, easier to test. So it forces you in a way like to do that. Also, fewer bugs and regressions. Like the example I gave before, where I refactor a code, or I'm even going to add like a functionality on top of an existing function, and then I'm running the test, and the previous tests are failing. It's like, oh, my functionality broke something. So your regression, you need to do a lot of things, test manually the whole process, and immediately there's regression already going on by just adding your functionality, running the test. All the previous ones are passing or failing. You get like instantaneous feedback. So regression is simpler, and it's straightforward. So, and then fewer bugs. So like some of the benefits of TDD. I work in a company where we use like a monorepo architecture. We have like a shared library, and then we have like 5 or 6 different applications feeding off the shared library. So, say for instance, we change a piece of code in one of the library. What we have to do is we have to test manually all the 6 applications to make sure that we didn't break anything. But because we write tests, we can easily run our tests and say that, oh, okay, we're safe. If something is breaking, we know we've done something wrong. So it's easier. It makes your life simpler. You don't get late night calls to say, oh, you broke something in production. You consider that. So that's some of the advantages of TDD. I mean, there are others, but I mean, just pick 5 examples, and yeah. So we have some type of tests. There are lots, but the core ones I think I know, and the ones I use like on day-to-day basis, and I mean, does everything for me. It's just like 3. There's unit tests, there's integration, and there's end-to-end. Since we are in the context of JavaScript or TypeScript, so I limited options. I mean, for other languages, there are different libraries that you could use to write your test. So unit test, integration, and end-to-end. So for unit test, there's some tools that you can use. Jest is like has been a champion for the longest time. But there's Vitest coming up now with Vite and Vite, or Vite, like some people pronounce. Pardon my pronunciation, Vite or Vite. And also, since we're using React, there's React testing library. If you use Vue, there's Vue test sheets used, and Angular, Svelte, all the other frameworks, they have theirs. But I mean, in React context, it's called React testing library with Jest or Vite. So what unit test does, just so you have a small function. Let's say you have a function to add 2 numbers or to capitalize a word, the first letter of a word. Yeah. So unit test is just it tests just the smallest function, the smallest piece of your code. Let's say you have a component, you have a button component, that's like an atomic component. You can write a unit test for that, right? Just test that simple component or that simple function. We have integration test. Integration test is more of say I have a parent function that has 2 other functions. So I have a function to log in, or I say I have a function to what example can I give? So I have a function that has, so I have a big function where I have 2 other functions coming in. I have like it's not a modular function, it's not doing one thing, it's like a collection of different components together. So I want to test how they interact with each other to see if I get my desired outcome. That's not a unit test anymore, because unit test is like just one component, a piece of your code that you're testing. Function to add 2 numbers together, function to capitalize a word. You have a validation, password validation. function, you want to write a test to make sure that, oh, my validation comes from is going to work as it's supposed to be. That's like unit test. But when you bring the password validation, you bring the maybe another function, you have a big function that does series of validation. And at the end of the day, you say, oh, everything about you is fine or something like that. That's more of integration test because it has like more than one component, like testing different components together to make sure that everything works as it's supposed to be. So that's like integration test. It tests interaction between modules, multiple units of code, multiple components coming together. So that's like integration test. The last one is end-to-end. End-to-end test. It tests the complete user workflow. Like say I have a login page. I want to test the complete flow from the user going to the password, typing in, going to their email field, typing in, going to the submit button, clicking on that, and based on if they gave the right credentials, they're able to log in, or to give the wrong credentials. There's an error message that shows invalid credentials, something like that. It tests the whole workflow. It's much slower, but I mean, it does the work better than the tool because it tests everything, whole workflow. Say I have an application, I have a function, I have a page that does bank transfer, say withdrawal. I want to withdraw or send money to somebody. I have a whole page. I want to test the user flow from putting in the account number, filling in all the required details, and sending the money. I want to test that entire interaction. I mean, you could write an end-to-end test for that. So you see if everything works fine, your validations are fine, and all of those things. So that's more like end-to-end test. So test the whole workflow. Like unit test is testing the small part unit of your code. Integration is testing module, like a module where you have multiple units, and then end-to-end is testing the whole user workflow, register, login, all of those things. Yes, so I mean, so I give examples. So for instance, in unit test, I have this function that says add. It takes in two numbers and it returns this. This is like a unit test kind of thing because it's like a small function. I want to test that. Let's say I pass in the first number as 1, second number as 2. That's going to be 3, right? I want to test that this function is doing what it's meant to do. So I could just write the unit test for this. So this would classify as a unit test, right? Integration test. So this is like more React. I have a hook that helps me to get the user from the database or from wherever. I have a check if probably the user is still, I mean, the API call is still being made or something. I render a loading screen. When I get the data, I render the data. If I want to write a test for this component, it's going to be an integration test because it has like the hook, which interacts and gets data, and then yes, an if check, which is if it's loading, and all of those things. So this is more like an integration test. I would have to check if I can. So if I'm to write a test for this component, I will check prevention when data is still being loaded. Is the loading screen being shown? Yes or no? I have to test that. So when I get the data, is it being rendered? That should be rendered. Yes or no, depending on what you want to test or how you want to structure your test. So this is more like integration test. I mean, if I wanted to test the user hook itself, I would write a unit test for that. So this is like more two components coming together, integration test. Then I have end-to-end test. So end-to-end test is so with the way end-to-end test works is, this is an example using Cypress. It does it as if a normal user was interacting with your system. It would open up a web page, click around, fill in forms, all of those things a normal user would do. End-to-end test does that for you. So that's why it takes more time, but it is essential to write. You can test just a small part of your component with units, integration, more things together. If you want to test a whole user workflow, you would use end-to-end test. So this is like an example of a search page, right? So the way end-to-end test, if I launch the end-to-end test, I would write assertions and all of those things. Take this input feed, type into it, take this, select currency, and click on this button, and then I write my assertions. If it is successful, I should see this screen. If it fails, I should see this message and all of those things. So this is end-to-end test. I could just show an example. Just run example end-to-end test. Just to show how it runs. Quick one. Give me a minute. Okay. It's not the sound. It's coming up. Okay. So this is like, I'm running an end-to-end test from like one of my projects right now. So it's okay, end-to-end test. Then it's going to ask me what browser do I want to use. So it's like human interaction. It's going to spin up like a Chrome browser. If I say, okay, Chrome. Come on. Okay. Yeah. So this is going to restart the test. So I have a test saying search. And then I have two tests here saying it should show search results and it should show an error, right? So I have two tests basically, and if I run the test, I'm going to show the assertions also, and I'm going to show the main application. So it does everything, goes through everything like a normal user would. Select this input field, type into it, select the currency, select another currency, and just click on this button. So I'm just going to show the code briefly. So for this end-to-end test, I'm using Cypress. It's a tool that helps to write end-to-end tests easily. So I always like to split my test into three modules or under three headings, which is prepare, act, and assertions, right? So this is like preparing the requirements. You can just probably ignore this. This means I don't want to call the actual API. I just want to create a mock and then return a custom response stuff interacting with the actual database, just create a mock. The assertion is select the amount field, type this into it, select the label for the currency from, select this currency, select this label, select this currency, select this, assert that the URL is correct. And then I also do some other assertions to make sure that, okay, everything works fine. Then I'm also testing if everything does not go on fine, what happens? I mean, the requirement says I should show a toast and all of those things. I'm writing those assertions just to test that everything works fine. So tomorrow, if I want to add a feature or I want to refactor some of my code, I could just easily run the test after doing my refactor. And if something breaks, I know, oh, I broke something. I didn't refactor well. If it works well, I know, oh, okay, I'm fine. I didn't break anything. So, I mean, this is just like we'll get in other like sessions where we'll write some end-to-end tests and all of those things. But yeah, I just thought to show this briefly. I'm just going to go back to my slides. I'm going to close the
Wilson, I'm sorry, just we have one question,
okay.
but I suppose maybe you have already planned that, but Monica is asking if you can show how does it look when the test actually fails. So you are running the test and there is a problem and then the test will fail. So how does that look? Maybe later. or maybe you have already planned that, so just
Yes.
let you know.
Okay. Yeah, that's fine.
Okay.
Yes. Okay. All right. So that's end-to-end tests, and some of the testing tools, just V-test. I mean, React testing library, Cypress, like I just showed earlier. There's Playwright, and then there's Supertest. Mostly for front end, you would use Jest or V-test with React testing library, and Cypress or Playwright for end-to-end. Supertest is more of backend, where you would check your APIs are returning what is meant to return and all of those things. Okay, so this is where I would like to some live coding, just to show us how TDD works. This is going to be simple, functional component. Not component, a simple function. Just write the test, write the code, and we see it fail. Then we write our code to make it pass and all of that. So, awesome. So I'm just going to drag my VS Code. Where are you? Okay. Okay, so this is a new, I'm just going to initialize npm. Just, I mean, when JavaScript and ecosystem, right? And then I want to install Jest and use it to write my test, my unit test. So I'm just going to initialize npm. Okay, then I'm going to install Jest. Okay, I got you. Okay. Okay, so then I'm just going to update the command for this. So just so when I run my test, I usually run my test right now. I don't have any test, and yeah, could not find any test because I mean I don't have any test. So I'm going to write a test. Say password validation. Node.js. Okay. And say I run my test. I run my test again. It's going to fail because I mean there's no test. Obviously, it should fail. So I'm just going to write the requirements for my password validation. Just one uppercase. Awesome. I'm gonna use it. At least one lowercase. At least one, and at least one special. Right. Okay. At least 8 characters long. Right. So I'm just going to start with the tests. First thing you do is to write a describe block. That's why you describe what your test is about, right? Just don't write it. Do that. My AI knows what I want to write. So it's going ahead of me. But yeah. So this is the describe block, and then inside there is where we define all our tests. So we could write tests based on all of these criteria, right? This, no. So I could say, okay, test. I could say should be password should be at least characters long. This is a valid test case. We call these test cases. This is the test case. I want to make sure, okay, password should be 8 characters long, right? I'm going to do quietly. This is 1, 2, 3, 4, 5, 6. This is 6. This is what I call prepare. So I'm preparing the test cases, what I'm going to use for my test case. Then I'm going to, okay, this is what I call acts. This is actual action. Then the last thing is assertions. I'm preparing the what I need to run the test, which is the password. This is acts. This is action that occurs, and then this is like what I expect the result to be. So based on the requirement of a password validator, if we do this, the result should be false because I mean, obviously, this is not up to 8 characters, right? So we're just testing this particular one. Let me mark this up. At least 8 characters long. This is what we're testing for. And then our password is just 6. 1, 2, 3, 4, 5, 6. And then when we run it against our function, we expect it to be false because I mean, obviously, okay. Then we're going to run this. Obviously, it's going to fail because we don't have a function. So this is what TDD is all about. You write your test, then you go ahead and you write your function. So I'm going to go ahead and add a function called word validation Jest. Okay. And then it's going to take in password. And the first requirement is at least 8 characters long. So I'm going to copy this. Then I'm going to say if password length is less than 8. It needs to return false. We want it to be at least 8 characters long. And we can do model.export. So we can now use our function, import it, and use it in our test. So it will stop complaining about this, and our test should work. So I'm going to the import. Now we can construct this. Yeah, I can check this out. Yep. And we can run our test. Password validation. Okay. If password length is less than 8, return false. What's the error? Expected false, received undefined. Okay. Now let's stop. It's less than 8. Okay, let's come back in. Password validation equals to this, result equals to this. This should work. Oh, I don't know. I didn't do anything. It just worked. Yeah, so first we were able to write our test. to fulfill the first criteria that it must be 8 characters long. We wrote the test. We said our password is 6 characters, and we passed our password to a function, and then this should be false because it's not up to 8 characters, which is what we've done here, right? Okay, so the next criteria is at least one uppercase. So what we can do is just write another test just to check that we have at least one uppercase in. So we can do another test. Should have at least one uppercase, like that. And we do this. We do this. Stop. Then we're going to prepare our tests. Prepare. And this time around, we're going to make it 8 or more characters. So 2, 3, 4, 5, 6, 7, 8. So this is 1, 2, 3. Yes, so it should fulfill the first criteria, which is 8 characters, but it should fill because I mean there's no capital letter here. So I'm just going to okay, and then expect result that to be false. So assertions can have as many assertions as you want. A lot of helpers for this. If you check Jest documentation, I mean we'll check some later on. We'll see a lot of these other things you could use to do your assertions. Since we're expecting Boolean, it just makes sense. Is it true or false? Yeah, so should run this. Yeah, and this should fail. Right, because we don't have a function yet. So at least one uppercase selector. So you're just gonna use regex for that and say just gonna regex and follow. Okay. This is, I mean, it must be at least one uppercase character there. Okay, so we have our function. No. Come back to a test. This is a password. This is this. This is this. We run our test again. Issue still failed, obviously. One uppercase. Do we have uppercase? Oh no. Sorry. Test password return false. Return true. Ah, God. So if I had not written my no, this is false. Stop. But this is if not uppercase. Yep. If there's no uppercase, return this. Return false. Awesome. Okay, so let me see. Password is this. Okay. As password equals to this, cons result equals to I'm validating my password, and my result should be false because this doesn't have any uppercase. Something. That means something is wrong with my code, obviously. So I have to check. So that's what TDD does for you. I mean, I'm saying my criteria is at least one uppercase letter. And then I'm writing my code. There's no uppercase here. This, and I'm saying expect results to be false.
So, Wilson, you're expecting to be false because you have set in the function
Okay.
to return false, and you're actually checking that it is false.
Yes.
So it is passing because
It is passing. Yes.
yes. So if you would say, for example, you want it to be true, in that case, it would fail because the password validation wouldn't is not passing actually. So
yes, you're correct. Yep. Oh yes, which is actually correct. So this should be false because there's no uppercase here. So our validation should not pass. Thank you. Almost. Yeah. So my test is good. Thank you for that. So yeah, everything looks good. So there's no capital letter here. There's no and then based on our function, we see if there's no capital letter there, then it's not valid. So it's false. Okay, thank you. Second one is, or the third one is at least one lowercase letter. Okay. So I'm just gonna copy this. And I'm gonna copy it. So that is one. I'm gonna check this lowercase. And I'm gonna change that. Okay. I'm gonna change everything to capital letter and just add some numbers. 3, 4, 5, 7. And it should fail. Obviously, because we don't have any lowercase letter here. And the validation is going to look similar to this. And I'm just going to change this to small, I'm just going to comment this out right now. Okay, then I'm just going to run the test first. Obviously, because it's undefined, just because we don't have our function yet. And I'm going to bring back the function. I'm just going to comment the comments. Okay. And can go ahead and just write and make this again. And it's passing. If I change this to small letter, wait. If not, oh yeah. See, I made a mistake. Z, it's a Z. So with that, I was able to catch, and yeah, it failed because we said if there's no, there should be at least one small letter. If there's no small letter, then it should fail, should return false. But yeah, I have just changed the Q to small letter, and then it failed. So if I change this back and I run my test, everything should be passing. Awesome. So if peradventure had made that mistake and I didn't know this was A and it was passing, it's supposed to be A to Z because I mean alphabet is A to Z. So because I had A, it was passing, and peradventure I didn't check that well. I'll just push this code to production, and just because this was A, would have pushed something wrong. So thank you, TDD. Yeah. So the next criteria says at least one number. So I'm just gonna copy this and should have at least one number. So I'm just going to get rid of all of these numbers here. I'm going to make sure it's 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. I'm going to make sure it's 1 capital. 8 has password validation expect. Okay. And then I'm going to try and I'm going to run my test again. It should fail because we don't have the criteria, we don't have this function, don't have this in our function yet. So I'll copy my regex again. So this is this regex just checks if there's a number. If there's no number, it should return false. Awesome. The password should at least one number. Password. This. Okay. That's good. And okay, there you go. Paste the passwords. Come back here. Let me try this. Invalid password. As capital as this. No, I'm not adding that. At least one digit. Numbers. And I'm gonna run my test. Yes. Fine. It passes because we don't have any number here. So you can introduce a number. It should fail because now there's a number, so it's no longer valid, right? So if I pick out the number, it should work. Awesome. Then the last criteria says at least one special character. Okay, so I'm going to write this scenario. So at least one special character, and just gonna copy this. It should be fine. This false, yes. For run the test, it should fail. Oh yeah, it will still pass, obviously, because yeah, because it's not still in line with our criteria. I'm just gonna have a special character there. Just yeah, it was the pass. Yeah, because obviously it's more than 8. It has a number, and there's a special character. It doesn't count about the special character right now. Okay, awesome. Do we understand why this is still passing? Let me see. Yes, screen. Okay, so it's basically still passing because based on all the other criteria, it's still false, right? So this is as capital letter as numbers. Okay, yeah. So if I introduce. Awesome. Nice. Okay. So we have to be careful with when we're preparing our test, basically, because you can have like false positives, right? So you have to be really careful when you are preparing the criteria for your test, so you don't have false positives. Because if we had done like that, oh, it works, and then everything will pass, and then for your code, it's not actually working. So you have to be careful for false positives. So I'm glad you caught that. The next scenario, what do we want to write? So he must have at least one special character. Okay. I'm gonna copy my rejects. This is the rejects for special. Just paste it here. Then if all of this, if it goes through all of this and it's fine, we want to return true. And password is valid, right? By the time we check the characters, one uppercase, yes, one lowercase, yes. It has a number, yes, a special character, and the last thing is just return true because I mean that's fulfilled all our criteria. So, which is so the last thing is to test that password should be valid, obviously. Somehow my hair right this. Because if you take a look at this password, there's capital, there's small, there's yep, there's number, and there's a special character. So this should be fine. Awesome. So we've been able to write following the TDD principle. We've been able to write a test that checks for a password. Just we've been able to test this criteria or these requirements, write a function, write the test. It failed, we wrote the function, and we made it pass basically. So say for instance without this, if I open this test, someone who comes to this code just by reading this test, they should know what our function does, clear understanding of what our function does, or yeah, before even opening this code to read. So like documentation, basically. So it's like a unit test, because the test just one piece of code, unit piece of code. So let me go back. Do you have any questions?
Yes, we have some questions. So this was great presentation. I mean, this live coding, I think it's very demonstrative. So we have just one question, but I have tried to answer. I'm not sure. Rahava asked if we need to install Cypress RTL, right to left, if we want to test with certain languages that are from right to left, I think. So since I'm not familiar, I just asked ChatGPT about this.
You want to test with Cypress? I didn't really get the question. Could you come again?
So, for example, this Cypress dot RTL, Cypress dot right to left
Okay.
is called. And the question is, do we need to install that probably in order to test if you're developing with languages that are actually from right to left?
Yes, you do. You need to install that. Yes. No, it's different. There's Cypress RTL for people that develop from right to left. Like I think some Arabic countries, it's not from left to right. They go from the other way around. Yes, so you need to install that package on top of Cypress. Yes, you do. It's like a plugin into the main Cypress package that allows that it's going from right to left. Yes.
Okay, thank you. And also, for example, thank you. So, Turdukul asked, so, for example, now we have seen this test is very simple. I mean, it is for a demonstration. But, for example, we have a big project, and sometimes writing tests for every little thing feels like overkill. How do you figure out what's actually worth testing on the front end? And also, in your opinion, which type of test gives more value in front-end development, unit tests or end-to-end tests? What would you suggest?
Okay, so I think it depends. So I'll give you like some of the advantages of some of them. So with unit tests, it's simple. It takes less time to run, right? With end-to-end tests, because it tests the whole workflow, you have to launch a browser and all of those. It takes more time to run. So I use a combination of both. For my simple components or my simple code, I use I use unit test, but for more, if I want to test the way the user will interact with the application, I want to test on certain flows, end to end. Say, for instance, I want to test the registration flow. I would write Cypress. I would use end-to-end test definitely for that, because I mean unit test would do. It's not unit anymore if you test end-to-end, because you start doing a lot of things. I mean, it's possible if you use React testing library, you can actually write it, but in that kind of scenario, Cypress or end-to-end test, even with Playwright, does the job better. That's what it's meant to do. That's what it was specifically built for. It does the work well. It does it better. So I'll say for me, or I'll say find a balance between with the two. If it's a small component that you want to test, unit test definitely. But if you want to test certain flows in your application, just do end-to-end test. Say you have a search where when you search, you update the URL, you call the backend, you have a page, you perform a search, you display results, you do so many things on that page. It's no longer a unit, it's no longer like simple component that just one thing. It's like a complex component, a complex bit that does a lot of things, a lot of interactions. So in that kind of scenario, end to end makes more sense, because even when you write your test, you launch the browser, you see the interaction step by step, you see where it breaks, you see everything, the flow, and all of those things. So yeah, I'll say for you, small pieces of code, just write unit test. But when you want to test a whole interaction, a page maybe has so many components and there's a lot of interactions on the page, I'd say just go for end-to-end test with Cypress. It does the work. Playwright is lighter than Cypress. It's new. It's a new kid on the block. It does the work well also. So yeah. So I checked actually. The RTL you're referring to is actually React testing library. There's a way to,
Yes.
yes, it is React testing library. Thank you. Who said that? I think Trey. Yeah, it is React testing library. Yes, you can actually use React testing library with Cypress. So Cypress has its own, the way you write his own queries. It looks more or less like what's it called now? It looks more or less like jQuery in a way. The way you write the assertions, it looks more. But if you want to use assertions from React testing library, like get by test, things like that, you can add React testing library on top of Cypress, so you could use assertions from React testing library in Cypress. Yes, if it's out there, I checked, and I actually have an example of using React testing library with Cypress, just to make the query easier. If you use the React testing library and you want to write end-to-end test, you can actually do it with Cypress also. Your assertions would be similar to what you do in your unit test. Yeah. Thank you.
Thank you. Yes.
Okay. Okay, so where are we? I don't know if everybody's interested in this, but yeah. Who wants to write a small function, right? Test for us could be like a function that just adds two numbers together. It could be a function that divides two numbers, and just write the test. Not me writing this time around. That was on the outside. So almost made numerous mistakes, but yeah. Someone else wants to just write a simple function, and who's volunteering? Anybody? Any takers? Nobody? Okay. So, okay. And that's it. So I have a quote here. Code is like emo. When you have to explain it, it's bad. So you don't, when you write your code, don't necessarily need to explain it. It should be simple, modular, and understandable. But then when you have to start explaining it, it is definitely bad. Thank you.
Thank you, Wilson. This was really interesting and informative, and I think everybody enjoyed. So I was just wondering how much experience are our attendees do our attendees have with programming in general and testing? If you were able to follow the code, because I haven't asked at the beginning how experienced are you, but so you're also all going to join the group. So please ask if there is anything that you not understand or would like to get some more explanation. Just please don't hesitate. I tried in the past to test my API call, but somehow I could not manage it. Will it be possible next week show an example of it too? Okay, I was doing it on Next.js if it makes any difference. Yes, because for I think for APIs, testing is a little bit different. Wilson, maybe you can also take this into account because yeah, for testing APIs, you yes, I think it's a special case.
Yes, that's always you could with APIs. You could either make API calls directly to your database, which is not advisable, or you can create a mock where you return the response that your API is supposed to return. So it's faster. There's no API call. Your test is faster. That's like the best approach. So you have to create a mock. Either you mock your exhaust or you mock your fetch. If you're using fetch, or you use a tool called MSW. I'll just mock service worker. I'll just put the link here. You could check it out.
Thank you. And maybe Savim, you can also take some part of your code and add in the Slack, in the group, so we can all see and discuss how we can help you to make it a little bit more clear. What are you trying to test? For example, I don't know, is it a GET API? And so maybe just a little part of code, if you can. Okay, so please join our Slack if you haven't yet. And also test-driven development study group. So I guess you have already joined, but if you have not, please do. And we have also a feedback form for this tonight's
Navina,
presentation.
sorry to interrupt. Can I please take a picture of everybody if it's okay, and some of you could turn your camera on so that we could share this moment on social media, and hope to see you all in the next session as well.
Yes, and Sadim, we will be back to you after this, after smiling.
Yes, sorry about that. Okay, I want to see a lot of smiling faces, please, and I'll just let you know once when I'm taking the picture. All right, get ready, say cheers. Here we go. Okay, one. Just a moment, let me take another one, please. All right, get set, cheese. Thank you so much. Navina, you're on mute.
Thank you. I said we have forgotten to take photo at the beginning, but it's never too late to take photo. So, Sevim, you have wanted to say something to, maybe you can also just speak if you feel comfortable, or you can paste in the chat, because I saw you have raised the hand.
Yeah. I had a question about Jest and the React testing library. When I was trying by myself again, I got really confused because some part of it was referring to React testing library, the Jest website. So what is the connection between them? I got confused about that.
Oh yeah. Yeah. So Jest is like a node or yeah, because we're in like node environment, Jest is the tool you use for writing your test, right? But React testing library is specific to React for writing your queries. Say, for instance, you want to create a mock, you use Jest to create your mock. It's like the API we're talking about. Now, if you want to mock your API, and you don't want to use MSW, the tool I shared, you could use Jest to mock and all of those things. But to write us queries and to write assertions, React team created a tool called React testing library that makes it easy for you. So you use Jest with your React testing library to write your test. Jest for Node environment, because in Node environment, React testing library is specific to React. So it has to go together. There's a new tool called vtest, Vite. So if you don't want to use Jest, you use Vite, but you still need to use React testing library to write your test. Does that make sense?
Thank you.
Okay, sure thing. I mean, next week we're going to explore writing tests, when we're like focused on React for next week. So we'll explore all of those things. What you need to write your unit test and your end-to-end test in React. Yeah.
Nice.
Come with your questions and then come with your code. We'll hopefully fix them together.
Great. Do you have any more questions? Please feel comfortable to ask. If not, we will end this great session now, and we expect you also to see you in channel on Slack. So please give your feedback there also, and ask questions. And we're looking for the next session. Thank you all for joining, and it was great. I'm sorry, I see one question from Liz. So how important is knowing using regex for TDD? Wilson, regex?
No, it's not important. It's not compulsory. It was because the function we wrote, we're using regex to check some things, do some validations. That's why I added regex. Like for instance, I wanted to check if there is a special character. It's easier done with regex. That way, I want to check if there is a capital letter or a small letter. If my function was simply to reverse a string or do something simple or add two numbers or divide or some other thing that does not require me to use regex, your function determines what you do in your test. So because it just made it easier to just check a string if there's a capital letter or a small letter or a number. So it just made it easier. That's why the function add regex. If you check in the test, there was no regex in the test. It was just in the function. The function add regex. The test didn't add regex. So it's not, if you don't know regex, it's fine. I don't know regex like that in a bit, but I mean, it's fine. It has nothing to do with TDD.
Is there some kind of the shortcut for regular expressions, some kind of regular expressions, or?
Yeah, regex is regular expression. Yeah.
Okay. So thank you. Okay, and one other question is, how much does AI play a role in your testing flows? Maybe Trey, you mean how much is it can be used like helping tool when writing tests, or I guess that is what you are asking. So can we make it quicker by using artificial intelligence? Yes.
Yes, everything is quicker with artificial intelligence. But you just need to know, sometimes it will write something, it will hallucinate and write something wrong for you. So if you understand what you're doing and you know the basics, it will be easier to, no, this is not what I want to write. This is what I want to write, and then you fix it yourself. But if you don't understand, it could write a false positive test for you, and you just be fine with that because you don't know what you're writing. So it's very important to understand. Same thing with using AI for anything. You need to know what you're doing. It just enhances and makes it better and makes it faster. But if you know what you are doing, then you can definitely use AI. It just needs to be double sure that what you wrote is good and the correct thing.
Yes, so I agree. So you must already have an idea of what you want, and it can be helpful for sure. But not just like letting it adding things, because maybe it can be wrong, or maybe you don't need that. So yeah, okay, but definitely it can help. Like we have seen giving examples already when you were programming. So if you know, okay, yes, I want this, so it's quicker, but you have to know what's going on. Okay, yes. So okay, and Trey is asking, I was just wondering if and how you are currently using it. So do you use it like maybe when you are programming in Visual Code, Visual Studio Code? Yeah, you have
I use AI because I mean it does, it makes my life easier. I use Copilot, so if that's what you're asking. So I have Copilot in my VS Code. Yes, I do.
Yeah, definitely helps. But again, if you are new to this, I think it's always good to learn the basics at least, to have some idea, and then I mean, of course, you can test with that and then learn with Copilot, but yes, you must understand the code. Thank you, Trey, for the questions. Do you have any more questions? You can also unmute and ask if you feel comfortable. Otherwise, I think we can say it is okay, all for now. Thank you, Wilson. Thank you so much, and to all others. See you on Slack and next week.